Okay, so what questions have we got? There's not much to go over because same stuff we went over on Tuesday, but if anybody has any new questions about stuff, we can talk about that.
I'm not sure.
I actually have a new question. Oh, go ahead, Barbie. Go ahead, Barbie.
No, you go first since you have internet.
Since you may go, yeah.
I may lose it. I just had a simple question about the homework. I may have to share my screen to show you what I'm talking about.
Yeah,
okay.
Let me enable that. I always forget to do that. Yeah, it's good. She's quit moving. That could be a bad sign. At least her face is not horrible when she's frozen. Sometimes we freeze in a really unfortunate position. Hers is a little concerned looking, but not awful. I've seen worse.
Every time I made a Flipgrid video for the kids to do something back to me, I don't know why I never took a selfie and replaced it because I would have the worst faces.
The YouTube the same way. The YouTube just takes a random screenshot and you almost always have your mouth open or doing something stupid. So I don't know. You could put a card on it, but I don't tend to do that. So anyway, okay. She's apparently gone away. Maybe she'll come back. So you can go ahead and ask your question, Barbie.
Okay, it was on the last section. 2 questions really of chapter 14.
Mm-hmm.
Is she back? Yeah, I think she's coming back in. The regular expressions, the pattern, and the class matcher.
Yes.
I don't know. I kind of got lost in the explanation, but if the first character has that up around the up arrow.
Yes.
It will accept any character.
Yeah, that's the wild card.
Oh, okay. So lowercase, uppercase, digit.
Mm-hmm.
Any little like mathematical, like plus and all that?
Yeah, it shouldn't matter.
Okay, so it says in line 7, which would be on page 593.
Okay.
The first asterisk, let's see, the asterisk after the second character, and I'm assuming the second character is what is in the brackets.
Okay, line 7, what? That's the matches.
The brackets, everything in those brackets, like there's 2 sets of brackets. So the first bracket is the first character.
Yes.
Is that right?
The first character has to be an uppercase letter, so it's between A and Z. The second character has to be a letter. The second 2 characters have to be letters, but then after that, it can be anything.
The second 2 characters, and is that because of the hyphen?
It's a range, A to Z. So the first one, a capital A to a capital Z. The second one is going to be 2. Oh, no, that's not correct. I can't see, my light's low. It could be anything. It's just one character, small A to Z or big A to Z. So any letter can be there, followed by whatever. Okay. So you need one capital letter, one other letter, and then whatever else you want.
Okay.
And then line 12, see, the first thing it wants to match there is going to be any letter. So the first character is any letter that you want.
Okay.
Of either lowercase or uppercase. And then the plus sign is going to be at least one, but could be more, of either a dash or any of the letters. Okay.
And why is that single quotation mark there with the dash?
Good question. I don't know. I haven't read the chapter yet. This next week's material.
Well, that got me. That little section was confusing.
Yeah, let me prepare a video
And
on
even
that.
the table that the, okay.
So if you guys go and ask what you're going to ask, that's okay.
And if I can, okay, you're just going to prepare a video for the whole chapter.
Yeah, like I always do. They'll come out Monday.
Oh, okay, great. It was just that and the digits that were confusing to me.
Yeah, the regular expressions are the most confusing of that chapter for sure.
I'm sorry, what was that?
The regular expressions are the most confusing of that chapter. Okay.
Okay.
And my
That's
guess
good to know.
will not be on the exam.
Okay.
So the other string stuff probably will be. Okay. Other questions?
And what about the regex, if I'm pronouncing that correctly? REGEX?
Regex.
A pattern matcher.
Yeah, that's regular. That's just regular expressions. That's all that is.
Okay. Because they didn't do a whole lot, but they gave one example. They gave a string with someone's birthday on page 600.
Mm-hmm.
And then when it was returning, it gave the statement from the first string and the last string. So is that what that particular method does? The matcher.
Okay, so a matcher is an object.
The expression matcher.
Yeah. Okay.
Because I couldn't really understand in lines 9 and 10, it gave a pattern expression. So was that expression supposed to be the pattern it was looking for, and that's what made it print out Jane's birthday?
Yeah, because on line 18 it says matcher is equal to expression. Expression is that variable pattern you set up on the other page.
Right, with the J in quotes and the asterisk and all that stuff.
Yeah. Yes.
Okay, that was a little confusing to me. Okay.
I'll talk about that in the video as well.
Okay.
That'll come out Monday. And again, that most likely will not be on the exam. Would be my guess.
Okay, good to know. Are you going over that tonight?
I can.
What we should. Okay, fantastic.
But no one has any questions.
And
yes.
Virgil may have some, but
what questions? No, nothing in particular. I just wanted to see if anyone said anything that sounded like it might apply to my homework before I turn the homework in.
Yeah, this one was not well formed, so it's not going to be. I can't be super strict on it, and it's not much. I mean, it should be pretty simple.
Yeah, the only things that seemed like could potentially, the only things I could think of that would throw an exception would be entering something that's not an integer for the numbers, or entering something that is not one of the menu options, or
Right.
division by 0.
Right. Yep.
Oh, actually, now that I think about it, like, how do you account for if you have two potential exceptions of the same type? Like the thing not being an integer, but also the menu choice being wrong would both be input mismatch exception, wouldn't they?
I would deal with it not being on the menu in a different way, in however you're dealing with that, either the switch or the whatever, because that's not really an exception. That's a program logic issue, not an issue with the compiler.
Okay.
So I would just handle that like we always are.
Yeah, that's how I had it originally, and then I was like, well, I guess I could see this being an exception too. So
I mean, you can make your own custom exceptions. It's just that's more work than you typically would want to do.
Yeah.
And Dr. Fraser,
if it's something that could cause two errors, then you have to figure out which is the more important of the two. because remember, it's going to take the first catch that it finds that applies. It's only going to do one catch.
Yeah. Well, what I ended up doing was in the catch, because the input mismatch from next int doesn't have any message in it or whatever. So all I ended up doing was putting in my catch: if message is null, then do one thing, otherwise do another thing.
Right. That makes sense.
But I didn't know if there was a better way to handle it than that.
There's always a better way. We may not think of it, but there's always a better way. Yes, Barbie. Back to you.
On the digits and the bases, I think it said the radix, you choose a base of characters or whatnot. I thought that was a little confusing with the example that they gave, because they were converting digits to characters
Right.
with a base of 16.
Right.
So I wasn't sure how the indexing worked on that.
What page are you on?
589.
589. Okay. Let me see. See, if I know you guys have any questions about this, I would have read the chapter before today. But I haven't read the chapter.
Well, so far that's all I've done. It took me a couple days. It was had to
So
go back and
just
reread.
right? No, that's the radix you're getting it from there. I'm with you. Okay.
I'm sorry.
I'm just trying to understand what they're doing here. It's a weird example.
It looks like they're toggling between ASCII and readable characters.
Not sure what they're doing exactly.
We're talking about the radix. That's the number system base, isn't it?
Yeah, it looks like.
Mm-hmm.
So like on the first one, convert character to digit, they're doing A would be hexadecimal. Well, no, it wouldn't be hexadecimal 10. It would be decimal 10. Like hexadecimal A would be decimal 10 is what it looks like going out at the bottom of 589.
Right.
590, converting character to digit. 13 becomes lowercase d. I don't know the ASCII table well enough to know if that's right or whatever. But
that's still on hexadecimal. That's weird that it's a lowercase. That's what. Okay, so I understand the first example, because in hexadecimal, when you run out of digits, and this may be where it didn't explain it, Barbie, after a 9, you go to an A, then a B, then a C, then a D, then an E, then an F.
Oh, okay. If it did, I didn't get that.
Yeah, it may not.
I don't think it did, but
No.
I think they were kind of
So we're converting, in the second case, a character to a digit.
I think they were vague on that section in the master.
Yeah, it could be.
But
so that's taking the next character and then it's doing whatever the character.digit function is.
ASCII code for lowercase d. But on the other hand, if A is 10, D would be 13, and maybe it's just showing as lowercase by default instead of as capital.
Yeah, that is weird.
It's still hexadecimal D.
Yeah, I know what it's doing.
But we probably wouldn't have anything like that either, right?
Nope, doesn't sound like it. But again, let me read the chapter. I'll prepare a video, then I'll tell you what you need to know on that.
Yeah, it says in that paragraph, for example, the decimal integer 13 in base 16 has the character value lowercase d. Lowercase and uppercase letters represent the same value in number systems.
Right.
So yeah, it's just doing its lowercase by default, which probably would have no, it doesn't have a lower ASCII.
Yeah, it's weird.
Yeah, it's just basically all it's doing is converting between decimal and hexadecimal, it looks like.
Yep. Which is straightforward enough, but it's a weird way to go about it. So
Yeah.
yeah, the video will point out what you need to know, what you don't need to know. So should be good.
Dana sent a message through email to you.
Okay.
If I don't know if you have time to read over that and answer that question in the video or not.
I can see it.
Her internet's unstable.
Yeah, that happens. I don't see a message. That's weird.
Maybe it might take a while.
It may.
I
Yeah, there's no messages. It's weird.
I know sometimes in class when I would even email students, like right there, up for a code or something they needed to play, and take a little bit.
Let's see if it's here. Oh, here we go. Okay.
And who knows how far south she is.
Oh, she's going to Universal. Orlando is about in the middle of the state, if I remember right.
Okay, let's see if I can pop this up here. Maybe.
Of course, we don't know that she's in Florida yet, Virgil.
She may still be in Virginia.
Yeah.
She may have a long way to go. Okay, so what am I doing? That's the question. I want to know what I'm doing, because I don't know what I'm doing. My algorithm is not sufficient to handle this. Okay, so here's the code. Look at this. Okay, so I have her code. Let me share that. We can see what her question is. Maybe we all can help her out. Now I have to find you guys again. There you are. Okay, so now where's Eclipse? There's Eclipse. Okay, so here is her code. Her question is, the way it is now, it does all four when prompted. Okay, so let's see what she's got here. So she's got her scanner, she's got where the exception's coming in, there's her class, she's got the first integer, second integer, and the arithmetic operation that she wants to do. Okay. And then she's got the functions here. Okay, so down in here, she's getting our scanner, she's setting her loop continue to be true. Here's her loop. Okay, so what operation would you like to use? She gets that. Okay, yeah, it's because there's no, you need to have a switch or something. Because when you get which one you want, it's just doing all four of them no matter what. Okay, so in here, future Dana, when you read this, you basically need something like a switch. Arithmetic operator or operation. Okay, so basically for case one, you do this one. Case two, you do that one. Case three, case four, and you can do that whole switch inside of this drive. And that way, that'll let your code pick which of those it's going to do. Okay.
Up at the top, she had her first integer, second integer listed as static. Is that not going to cause problems?
I don't know.
Oh wait, no, I'm thinking of final.
Yeah, they're not final. I don't think you need to declare them static in this case, but I don't think it hurts anything.
Yeah, no, I was thinking final.
Yeah, now final would cause trouble. Yeah, but that's the issue, is that you have to pick which of these you want to do. And then the continue loop equal false would be in each of these cases. Unless, yeah, at all of them actually would be that way. Yeah, if not, it's gonna bring it back around. Yep, or you could also do if statements if you wanted to. Either way should work. Okay. Okay, so that was her question. Any other questions? We're ready to talk about the review.
Well, I do have one before you start.
Okay.
Since a lot of us are going to be going back to school the week of August, would you consider opening the test up next weekend unless anyone objects? I thought about, after working all day, I thought, well, 1 hour exams, because you did put it in 3 parts, but.
Yeah, I mean, it's less time to prepare, and that I don't know, because I can't do a review video after that. Send me an email. I'll think about that, and then maybe we can post it to everybody else, see how they're thinking about it.
And then, okay, send an email asking that.
Send an email to me, just so I'll remember that we had this conversation.
Okay.
I'll be able to respond that way. Okay.
Because then maybe next week we could ask our questions.
That's possible. That's possible. Let me think about it.
Okay.
I think about all the ramifications of that. But yeah, if we could get you done before your classes start, that would be a good thing, I assume, for everybody. So I'll see what I can do on that. Okay, so the final exam, it's going to be over chapters 8, 9, 10, 11, and 14. Okay. It doesn't mean we're not covering stuff in the first half of the class, programming languages, build, we're still doing for loops, we're still doing functions or methods, all that stuff, but we're going to focus on this stuff, okay? So it also means that the problems are going to be multi-part potentially, which means even that I could have you do something and there'll be 3 programs on the exam like there were last time. I could have you do part of a bigger problem on problem 1, and then continue on that to problem 2 and even problem 3 if I make a big enough problem. So in essence, it may be one giant program divided into 3 parts, or it could be 3 separate programs. I haven't made it up yet. Okay. Chapter 8 just gave us more detail on creating classes. And again, I call these classes, not application classes. Okay, so these are classes that we're using to model something in the world, a car class, an employee class, whatever. Okay. The main thing on that, the program or the problem is not going to prompt you for this. You have to remember what you need to do when you have a class. In fact, I could give you a UML diagram, and you have to be able to get it from that. Okay. And basically, the member data that you put in there should be private unless there's a really good reason not to be. Okay. You should have, if it's appropriate, and I will have to say, if I don't say, then you'll have to have accessors and mutators, gets and sets for each variable. Sometimes that won't make sense, and I'll tell you that. Okay. And then you have to have a constructor, at least one constructor. Okay. So Java by default puts in a no argument constructor that just creates basically a blank instance. But that's not usually what we do. Usually we're going to put at least one that takes all of the different member data. And remember, you can overload that, which means you can have one that takes 2 and 3 and 4, whatever. Okay, so you can have different constructors. Okay. Sometimes you'll have other things the program needs to do. It may need to override the toString function. It may need to do some kind of calculation function, all of that. Okay. I would get in the habit, although I'm not going to grade you on it, certainly, I would get in the habit of, you start with, in your class, you start with the member data, you then do the constructor, you then do the accessors, you then do the mutators, you then do whatever special functions that you have, okay? And by doing it in the same fashion, it's going to be easier for you to put stuff together, okay? On that, remember the this refers to whatever instance is calling it, okay? In the book likes, and I've started doing it just because I gave up doing something different, where your parameters coming into the constructor or the setters are going to have the same name as the member data. And then you just put the this to refer to the one in the instance. Remember, in Eclipse will highlight which one you're talking about, whether it's the one that's part of the class instance or one that's just a loose variable, okay? We also talked about static methods and static variables, okay? And in a class, they're not going to be static usually, like they don't have a main class, so they don't have the public static void main, because we're using them to create other instances. We would have something static if it relates not to the individual instance, but something that does everything, okay? So remember, the math library has a static variable for pi, for example, that doesn't vary based on which instance of it that it is, okay? So then if you have a method there, it would refer to all of the class, not just the instances, okay? So make sure you have that static part down, okay?
Can I ask a question?
Yes.
Class, is that like kind of like subclass?
No, I'm just saying class to make, remember we do everything in
I remember when you said that, but I wasn't sure if that was just going to refer to like the main class where the subclasses would be coming after. Okay.
No, a class is what any other language would just call a class. It's where it doesn't have an int main, or it doesn't have a public static void main. It's defining a vehicle, an employee, whatever. The other kinds of classes we do in Java are like when you write a program, that's an application class. So before we did classes, we still did class files, okay? So I'm just saying here, these are, we're doing here the object-oriented sense of the word class. That's what I'm calling a class.
Okay.
So anyone we've done chapter 8 on, since midterm, all those have been what I would call class classes, except the test programs. The test programs are not class classes, they're application classes. They have a main method, okay? Let me also say that a program, and we've seen this in the homework, a program doesn't have to say, create a test program. You still have to create a test program. You don't have to say it. I'm getting confused what I'm saying. You always want to test your classes. Whether the problem asks you to, doesn't matter. Always create a test. And your test should create instances, at least one, and one per kind of constructor you have. Okay, you want to check off every single function. So if I have a class, whatever it's called, class X, that has 3 constructors and 6 methods, then I need to create 3 instances, one each for all 3 of those constructors. And I need to run all 6 of those methods on one of those instances, okay? So make sure you test everything. And again, I may not say write a test program, always write a test program, okay? You have no other way to know if it's working, okay? Because you can write a class that doesn't work and run it, and it'll say, yeah, whatever, fine. You asked me to do nothing, I did nothing. So you need that test program to make sure that it works, okay? So in chapter 8, we're not going to do enumerations at all. You can just strike that from your brain for the test.
What section is that?
I don't know.
Oh, okay.
I have notes here I'm going from. And then
No enumerations?
No enumerations, no big decimals. Okay. So that's what goes away in that section. Chapter 9 is on inheritance. Remember, the inheritance is all about making subclasses. We also call that specialization. Okay, so we had a shape, now we have a 2-dimensional shape. Now we have a circle that's a 2-dimensional shape. Okay, so with that, we're going to use the extends keyword. We're going to say, you know, class circle extends 2-dimensional shape from the homework. Okay. With those, we have some special rules about things we have to deal with. The constructor has to call super first. So make sure you have examples of that you're familiar with, that you're basically going to, if we have 3 pieces of data in the superclass, and then a particular subclass adds 2 more, then the constructor for the superclass would just have the 3 pieces of data. The constructor for the subclass would take in all 5 pieces of data. The first 3 it would send to the super constructor, then the other 2 it would deal with itself. Okay, we've had examples of that, but just make sure you keep track of that. If there's a subclass, then it's the same way. The subclass doesn't know about anything except its parent. Okay, so in that same example, if we had 3 pieces of data for the superclass, 2 more for the subclass, and then 2 more for the subclass, paper and pencil, then in the subclass, when you call the super constructor, it wants the 5 pieces of data. It's going to deal with its own 2 itself. That would then, when you call that constructor, it would call the other constructor. Okay, so you never have to call the grandfather or the great-grandfather. You only have to call the super. Okay, and then if that super needs to call its super, it will keep calling from there. Okay. The super in general, we can use super. Remember, if you want to call a function that, if there are different versions of a function or of a method, you want to call the one that the super has, you can put the word super dot, get to that, which can be helpful. We use that in the program in the carbon footprint one, where we wanted to be able to figure out what the super and what its class was and all that. Okay. Remember also that we've added, in addition to public and private, we added protected. So if you just use private, which we often do, then the subclass would have to use the public accessors and mutators to get to that data that's stored in the superclass. Okay. So if we had, an employee class with the name, first name, last name, then we had a hourly employee class that we're developing. I couldn't just say directly first name, last name. I would have to go, if they're private, I would have to go through the public accessors and mutators to view and change that. Okay. If you don't want to do it that way, then you can do protected. That's the new word. Okay. And the protected is going to allows subclasses to treat that data as if it were their own. Okay. And that's the octathorpe. Is that the symbol? The UML diagram? Let's forget that. I think it's a little hashtag for a protected. It's plus for public, minus for private. I think it's a little hashtag for the protected. Okay. And again, it just depends. You can't say you always do protected or you always do private. It depends on a whole lot of situations. And on an exam situation, I would tell you which one to do. Okay. But again, here's where you lose points. If I tell you to use private and you just access that data directly from the subclass, then it's just not going to work. Okay. So if it's private, you have to use the accessors and mutators. In the same way, if I tell you to make it protected and you do, but then you still use the accessors and mutators, then you've really done it wrong. Okay, so if you have protected, you can just directly say what you do. Yes, Virgil.
It's something that's private in the parent class.
Mm-hmm.
Do you have to call it as super dot set whatever, or can you just say that's like set whatever?
No, it will inherit those methods.
Okay. Oh yeah. No,
yeah. Yeah, because there's not a different version. Yep. Okay. That's it for chapter 9. And I think we're doing all of that. There's nothing there to get rid of. Chapter 10, polymorphism and interfaces. Okay. Remember the whole idea behind polymorphism is based on the idea of an is a relationship. Okay, so if we have an hourly employee is an employee. Okay, so if you have a function like print name that takes an employee, the employee has first name, last name, social security number, let's say, then I can also send it an instance of hourly employee because an hourly employee is an employee. Okay, so it's the idea that if a method takes a superclass as a parameter, it will also take any subclass. Okay, because again, the subclasses have everything the superclass has, adds more detail. Okay, you can sometimes do it the other way around. You can sometimes, but you can't rely on that. You can't, in general, if I write a method for hourly employees, like to calculate salary, I can't just send in an employee because it wouldn't have all that data. Okay, if you work it right, you can, but in general, it's not a good idea. Okay, so you need to be able to create these polymorphic methods, see how they work. Okay, we also in this chapter talked about the idea of abstract. Okay, some of you on your homework, you had class files, but it's really weird because I thought it seemed like it gave me a problem. If you have an abstract class, you don't need a constructor because you're never making that class. It seems like it wouldn't even let me make it, but some people did and it worked. So maybe I've got that wrong. But in general, that's the idea behind an abstract class, is that it's never going to be instantiated. If you make employee as an abstract class, you'll never be able to say employee Bob is equal to new employee. Okay, you can't do that. Okay. If it's not abstract, then it's concrete, a concrete class. That's one that you can make something from. It has to have a constructor. Okay. You can also have abstract methods. An abstract method, when you put that in your abstract class, creates an obligation for all subclasses to define. And you don't define it typically in the abstract class. It's like the area, the get area in the two-dimensional object that we talked about. Okay. The get area was an abstract class in the two-dimensional class, which meant that any subclass of that, any child of two-dimensional class, had to implement that function or that method with the same signature, the same parameters, same return type. Okay. So that's where we use the abstract methods. Okay. And then the last thing we did in that chapter was the idea of an interface. That was the carbon footprint thing. And an interface, again, remember that most languages like C++ allow you to inherit from more than one parent. And that turns into, there's some issues with that about which one takes priority if there are two functions, two methods saying the same thing. So in Java, you can only have one parent. Okay, so there's no way to inherit. So you can only extend one class, not extend this and that. Okay, so to kind of get around that, we have this idea of an interface. Okay, and the interface then is a way to force some functionality on a bunch of classes, but they don't really inherit the normal way. Okay, so the example we did was with the carbon footprint. We're adding the obligation to create a get carbon footprint to a bunch of classes that are in other ways not connected. Also things like runnable is a class if we're doing thread programming. In the exception chapter, they talked about things being in the throwable interface, which means they can throw an exception. So, but that's the idea. You're adding you're compelling some feature on a bunch of things. It could be if you're creating, I don't know, a class that can, I don't even know what that would be, taxable, that could be something that you have a bunch of different objects that could be taxable. Oh, they gave the example in the book on payable, like an employee could be payable and an invoice can be payable, but in other ways they're not connected. Okay, and this allows your systems to have some consistency between different methods. Okay, and that's it for chapter 10. Okay, chapter 11 on exception handling. Just make sure you're clear on why you need to handle exceptions, and exceptions when something wrong happens at runtime. Okay, it's not a syntax error. Remember from probably day one in class, a syntax error is you've typed system.out.print and you capitalize the P. It'll never run. It'll never work. You've made a grammatical error basically in your code. Okay, but the exceptions deal with runtime errors. Okay, and if you run into a runtime error, if the user inputs something crazy or something weird happens, you don't want your program just to throw up a bunch of error messages all over the screen. Okay, you want, whenever possible, for the program to allow the user to fix their error and keep going. Okay, that's why you put the try block in a loop. But at the least, you want it to exit gracefully and say an error has occurred, we're shutting down. Okay, don't just stop in the middle. Okay, it also gives you the ability to clean up some stuff. So that's where the finally block comes in, where you can release some resources and make sure nothing crazy is going on. Especially, we didn't do files, but if you're doing files, sometimes your files can be in a not consistent state. You have to clean all that stuff up. Okay. So with those, we have the try block. Again, the try block is like, I think of it like a little fence. You're fencing in some code and saying this amount of code, I'm going to be looking for exceptions. Okay. If it's in the try block, then we're going to deal with that exception. If it's not in the try block and there's an exception, it's just going to blow up your program. Okay. It's not going to exit gracefully. Okay. So when we see an error, they oftentimes will throw themselves if you input something wrong, but you can also directly do an if statement and throw an error of your choosing if you want. Okay. And then after the try block, we're gonna have a bunch, at least one, sometimes more catch blocks. And that will be which particular exception was generated. Okay, so if an exception occurs, it's going to go to the first in the catch block and say, is this the exception that I did? If not, it's going to keep going until it finds the first one. Again, if more than one, if it's more than one error or more than one exception for some reason, then it's going to pick whichever the first one that happens. I'm guessing there's a way you could input something that would create more than one exception at the same time. So it's going to take whichever one it finds first. Okay. Remember how this works is that if an exception fires and it goes to that catch block, when that catch block is done, then it doesn't go back to the try block again. It goes to the end of the last catch and keeps going on. Okay, so again, that's why you put a do while loop or some kind of a loop if you want it to go back and ask the user again. Okay. And then the last thing in that chapter that I care about is the assert statement. The assert statement comes in real handy. And again, the assert is going to assert that some logical condition is true. And if not, it's going to basically stop execution of the program. Okay. It's not something you want to keep in production code, but it's something that's really good to have when you're testing to make sure things are acting correctly. Okay.
What did you say? What was that called?
The assert.
Oh, okay.
Yes. So you're asserting something's true, if not, it's going to blow it. Okay. So don't worry from that chapter about the finally clause. We're just going to pretend that doesn't exist. Don't worry about chain exceptions, and don't worry about creating your own exceptions. Okay. We'll just skip that.
Don't worry about finally, and what were the two exceptions?
Finally, chain exceptions, and then creating your own exceptions.
Okay. Thank you.
Okay. And then 14 we haven't got to yet, so I don't have any notes on that yet. But again, my thought, unless something dramatically changes by this weekend, is that we probably will not do the radix stuff or the regular expressions on the exam. It'll just be those string functions at the beginning of the chapter will be what you'll be responsible for. Okay. And I'll do another more formal review video when we're getting closer to the final. Okay, but Barbie does. I want to go ahead and throw out there to get you thinking. I know you guys have a big day coming up with school starting again, so yeah, gonna be a fun one with with COVID on the resurgence. It could be interesting again. Another interesting school year for us. So
yes, we'll all be starting in masks again. I've heard in Virginia.
Yep. In Tennessee, we don't do masks. In Tennessee, we decided we're just gonna. The governor's gonna say there is no COVID; it doesn't exist. So there we go. It's easy that way. So yeah, we'll see how it goes. I think the on-campus students, if you're either unvaccinated or you haven't shown student affairs that you're vaccinated, then you have to wear a mask in class. Same for faculty and staff. Although I think over 70% of the faculty and staff have been vaccinated already.
I'm not sure how they would mandate that on a campus though for kids,
Well, yeah, they can. They did before. They can mandate whatever they want. It's health and safety.
Are they, so each one has to produce that they've had the vaccine, but I mean, how are
or wear a mask. You have an option.
I know, but when they did that in Virginia, when they opened everything back up and, you were supposed to take it upon yourself if you didn't have vaccine to wear a mask. I just wonder how many people were conscientious and really did that.
I think that I know that all the signs in the stores here in Johnson City say if you haven't been vaccinated, you should wear a mask. I always wear a mask even though I'm vaccinated. I'm guessing it's the opposite. The people wearing the mask have already been vaccinated, and the people that think it's not real or doesn't apply to them are the ones that don't wear a mask. Would be my guess. But yeah, Wise did a good job. I think there was never more than 9 cases on campus, and that was right after people came back from Christmas. I know that when I was vaccinated, I went into HR. I didn't have to, but if I did and showed them my card, I wasn't part of that. They do the testing every week. They do 10% of the campus. So I got randomly picked once, I had to go in and do the little nasal thing. So they're testing everybody, or 10% of the campus population. Every week it's tested. and you have to wear a mask unless you show either HR or student affairs that you have been vaccinated. And faculty have a list that we can go to that shows who's been vaccinated, or who's been vaccinated and who hasn't. So we can require the students who haven't been vaccinated to wear a mask, or we can kick them out of class just like we did last semester. So I didn't have a problem with that last time. Everybody wore a mask because at that point everybody was wearing masks. So I'm hoping that won't be the case. But and faculty will vary, but you know, I'm paranoid about this stuff. I send students home, but if they come to class with a fever, or they're coming, oh, it's throwing up last night, I'm like, go now, leave. I mean, there's just no, colleges are too crammed in. There's no reason to spread your germs to everybody else. So, but yeah, I suspect some faculty will not be that diligent. They spend a lot of money putting up plexiglass panels everywhere because they didn't know that was useless. And they're keeping them up, but you know, it's aerosol, it's not direct. We didn't know. I mean, when they did it, they didn't know. If it's like the flu, or which tends to be more projectile from, you know, when you sneeze, that's one thing. So yeah, but I don't know. It'll be an interesting year. And at least
I know we did the plexiglass too, but I was thinking,
nope.
You know.
Yep, no, it's going to come right around that. But yeah, you've got little ones who can't be vaccinated. So you know your students have been vaccinated. So you've got 100% are not vaccinated. They probably also do not like to wear masks, which would be my guess.
No, they don't. And, you know, at some point, sometimes I think towards the end of the year, I kind of gave up on, if it's not on your nose, it's not working for you or for anybody.
That becomes your whole day. I mean, yeah. My daughter teaches ballet at the Bristol Ballet, and this year, she doesn't normally teach the little ones, but she was teaching the little ones this year. And they were supposed to wear masks, and it's a full-time job keeping them in their mask. I think they need little bubbles on their head, you know, that would help. So that would work maybe, but anyway. But hopefully it'll, you know, people will get vaccinated and it will go away and we won't have another year like last year, because that was kind of a crazy year. So anyway. Okay, any other questions on anything? And I will think about if we can do the test early, see if there are any other ramifications of that, and see how that goes. Because I will help you out if I can.
I'll send that email.
Yep, that'll compel me. It's like an abstract method. It compels me to do something. Send me an email because I'll remember it. Okay, anything else we can talk about?
I got nothing. I guess I'm not going to make any changes until I turn my homework in.
Okay. Okay. Well, I think I'm caught up on homework. Everything you've turned in, I've graded, I think. So
yeah,
I graded the last one today. So.
And thank you again for those video walkthroughs.
Okay. If you need more of those, let me know. I mean, I think if I were a student, I just can't imagine. When I was a student, I had no way to even contact my professor unless I went to their office during their office hours and hope they were there. The idea that they could do a video for me of explaining something, what a wonderful world we live in. So as a professor, I want to take advantage of that, you know, and there are faculty, and I know there are faculty at UVA-wise that don't want students to succeed. They pride themselves on failing a whole bunch of students. I don't understand that personally. Everybody makes an A, I'm happy. You know, it never happens, and that's okay too. I don't get depressed when they don't, but yeah, whatever I can do to make it easier. I can't open up your head and throw the knowledge in. So, you know, you got to figure it out.
Too bad.
Yeah, no. Yeah, exactly. But there's no downloading of data. But, you know, if I can do something to make it easier, then that's good. So we'll try to figure it out.
The only classes I ever got that impression from at Tech when I was there was the first year engineering class that all engineering students had to take.
Mm-hmm.
Something like 70% of people failed it.
Yeah.
Every year.
And the professor probably told you that first day of class, right?
Well, it did, yeah. And they like went out of their way to. I mean, there was like 4 or 5, I think 4 midterms in the final,
mm-hmm.
And they were always like a Friday at 6 a.m. So like before the dining hall was even open, so you couldn't have breakfast first.
And no coffee. That's horrible.
But yeah, I mean, the idea was that it's a hard class to get people who aren't serious about engineering out of the department.
It's a clear out class, and I don't like that concept, but we all do it.
And it was just the first semester. The second semester was like a breeze.
Yeah. You want to see how they're going to work and all that. Yeah, I know that forget which class it was. The first, it was a big class. It must have been when I was at the University of Louisville. The professor's like, okay, look to your left, look to your right. One of those people won't be here at the end of the class. Okay. So I don't know. I mean, the first programming class is kind of the clear out class for computer science. And typically it has about a half the students don't make it through the first programming class. And I tell them that up front, but not as a, oh, I'm going to get you kind of thing. But it's just, this is the fact. This class, you got to keep up. You got to be serious about it because the odds are not great for people to get through this class. You know, if you try, you have a shot at making it. But yeah, I don't like scaring people. Some people like scaring people. So I think the material's hard enough. You had discrete math. It was scary enough. You didn't need me to be scary about it.
And with programming too, I mean, some people just don't have the mindset for thinking about it the way you need to think about it for programming.
That's the big trick. And some can't, I think. Some genuinely, they play video games, so they think they want to be a computer programmer. Yeah, no, they're two different things. It's like saying, I like listening to music, I'm going to join the orchestra. No, there are different paths. And I think a lot of times kids are coming out of high school without enough math, which hurts them. And all the standardized testing doesn't really teach them math. It teaches them some multiple choice math, which isn't like programming. And then I think that students have to rework their brain on how this stuff works, which is hard, which I'm guessing is the point of this whole CS stars thing, that hopefully you guys can start introducing some of these concepts, even to your elementary school kids. Just, it's not memorize and take a multiple choice test. Programming is a skill, it's not knowledge in the same way. It's not knowledge acquisition, it's skill acquisition. You know, it's much more like playing tennis than it is like being a lawyer. So, you know, the students have to learn this algorithmic thinking, and there's not just an answer that falls out. I remember one of my best students I had at Tusculum was so frustrated the first semester that I had her the first week. She said, just tell me what you want and I'll do it for you. And I'm like, programming doesn't work that way. Other classes, yeah, here's the answer. Here's the technique. Programming, you've got to figure it out yourself. And some of you, not just you in this group, some of people in this class, and probably in the Python too, struggle with that. How do you tell a computer how to do something? It's a weird way to think. So yeah, that's the challenge people face. But yeah, I don't like to scare people any more than necessary. So anyway, okay. So that's it for this week. You got something else, Virgil?
Well, unrelated to all that, how hard is Python to pick up exactly?
Not very.
Okay, because I was looking at, I mean, I'm not part of this like stars or whatever. I'm not in the right, not in the right part of the state. I just saw this that they were offering over the summer. I was like, that sounds fun.
Yep.
And then I saw that the one that's going on in the fall is it's called data structures with Python. I was like,
yes,
oh, that sounds interesting, but I've never used Python before.
Yeah. Barbie, would you agree Python's a little more straightforward than Java, a little easier?
Yes, what always hung me up was the spacing though, because sometimes just, you know.
You need that rigor. I've read your code. Your spacing is not good in Java. It's all like,
I know, so this has made it a little bit more forgiving. I'm still not a critical thinker, I have learned, because everything is given to us from elementary on. I mean, we're given formulas and we just have to plug in numbers and, you know.
Yep. You know, it's funny.
I do like, I like that we're introducing this in elementary.
It is good. It's funny. My daughter danced ballet forever in Abingdon there at Highlands. And I think, do you know any people that dance at Highlands? Barbie, you're from Abingdon, aren't you?
My daughters did.
Okay, yeah. So my daughter danced there. Now she works at Bristol.
And I have a lot of students that do, yes.
Okay. But I remember the day that they teach dance as 1, 2, 3, 4 dance, you know, count. And then they had a choreographer came in doing some more advanced thing when she was probably about 11 or 12. He's like, well, you can't count. You just have to do it. And it just blew their minds because their whole world, the first until you're 12 in dance, it's count, 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 count. But then that goes away. It's like in music. You quit counting at some point and it's a whole other level of stuff going on. And your programming is kind of that way. Yeah, it's a way of thinking that we don't teach kids at all. And hopefully this will encourage you to do that with your students. But it's a good thing. But anyway, to answer your question, Virgil, I think your second programming language is always easier than your first because you know that you're not trying to struggle what's a for loop and all that stuff. Python's a little quirky in places compared to Java, and I don't know what else you know, but
most tech was mostly C++.
Yeah, that's what we saw.
You would do great then, because I feel like in class discussions you already know
Yeah,
way more than me. Maybe because C++, I don't know, but I think that Java and Python are very similar.
Yes, actually, C++ and Java are more similar.
Oh,
Python,
okay.
yeah, Python. I mean, they're all in the C family, so they're related. I would just there are some really good videos on YouTube on Python. I would just watch through some of those, or just grab a book, so you have that resource when there are questions. I don't think it'd take you 2 weeks tops to pick up Python.
Okay, well maybe I'll look into signing up for that other class then.
In fact, Virgil, this month, you may have missed it, Code Virginia is doing there's a possibility of a 6-day Python class, but you could do it in 3. You could probably, like get the basics, and then the 4, 5, and 6, I guess, go a little bit further. So you might be, and it's free classes.
Yeah, that would be useful. I mean, it's again, the basics. It's just how does Python do it? And that's all. That's what we've been doing in Java. If you know how it's done in C++, you just have to translate. You're not learning the whole new idea. The idea is fine.
Yeah.
Yeah. The weirdest thing in Python, there are no data types, which I know it hurt your head. I know it hurt my head too. Yeah, there are, but they're in flux. They're whatever you say it is. I can say A is equal to 10.
Structures in Python if there's no data type.
Well, that's going to be interesting. I've never taught data structures in anything but C++. And also, Python has built-in data structures like dictionaries and all that. So I'll be curious how that's going to work. But yeah, in Python, you don't declare variables in advance. You can just A is equal to this. You don't have to declare it as a type. And again, I can say A equals Bob, now it's a string. A is equal to true, now it's a Boolean. A is equal to 7, now it's an int. All in the same program. Which has its pros and cons.
I was going to say, it sounds like a very easy way to get yourself in trouble.
It is, but it adds some flexibility. The other thing, as Barbie had mentioned, the big thing is there are no brackets to do blocks. It's indentation. How do you know it's inside of the loop? Because it's indented over. And if it's off by 1, you're wrong. It throws an error.
Yeah.
It's interesting.
Dr. Carter said that was going to be the death of me, but
yeah, I think the misery. Oh yeah, Judith popped up the professional development thing off the code. Did you see that, Virgil? It's in the chat.
No. Oh.
Yeah, Jude has a link to the
Oh, okay. Thank you.
the Code Virginia, which is cool. But yeah.
hey, this is not a class question.
Okay.
I'll just email Jude later. Never mind, because I know he's the ITRT.
I'll stop the video and you can do whatever you want to do. I'll stop the recording.